Welcome back, chemists. In this video, we are going to focus on a problem-solving strategy known as dimensional analysis. This is something that you're probably going to use in your math class, you'll definitely use on the SAT, and probably in your physics classes as well. And so this video is primarily an introduction to dimensional analysis, and you'll definitely need your calculator. After this video, you should be able to explain what dimensional analysis is and how it is used in chemistry, solve multi-step conversions using dimensional analysis, use the appropriate conversion factors to modify base units, identify the units used in the SI unit system for length, mass, and volume, and use prefixes to write conversion factors, for example, centi. So dimensional analysis is a method used to convert units. It uses something called conversion factors. Conversion factors look something like this, where you've got 60 minutes equal an hour, 24 hours equal a day, 100 centimeters equals a meter, 12 inches equal a foot, or 16 ounces equal a pound. These are all examples of equalities. These are two things that are set equal to each other. They equal each other. Here are some important measurement prefixes that you need to commit to memory in order to perform dimensional analysis calculations successfully. So mega, you want to think mega million. It has the symbol big M, meaning is 1 million, like the mega millions, like the lottery. An example is 1 megameter equals a million meters. Kilo is up next. It has the symbol lowercase k. The meaning is 1,000. And then, for example, you could have 1 kiloliter equals 1,000 liters. Then comes in the base units. Now we can modify those base units, in this case, if we go smaller, with deci. So with deci, it has the lowercase d, and this means tenth with a th at the end. And so the way that you can write this conversion factor is 1 meter equals 10 decimeters, or you could say 0.10 meters equals 1 decimeter. I have an affinity for writing the first one, just because I like to use whole numbers as opposed to decimals, but either one works perfectly. Centi is up next. It's even smaller than deci. So centi has the symbol C. It means 100th. And so in this case, you could write it as 1 liter equals 100 centiliters. And notice that even though it says 1 liter, that could technically say 1 meter equals 100 centimeters. Or you could have 1 gram equals 100 centigrams. So you can switch out whatever that base unit is. Millis up next, has the symbol lowercase m. This is 1,000th. Again, with the th at the end, we're getting smaller here. So 1 gram equals 1,000 milligrams. Micros up next. It has the symbol, kind of looks like a U with a hook in the front. That's the symbol mu. And that means millionth, again with a th at the end. So in this case, you could have 1 meter equals 1 million micrometers. Then we have nano, which is 1 times 10 to the minus 9, teeny tiny. So we would say, for example, in this case, 1 meter equals 1 times 10 to the 9th nanometers. Pico has the symbol P, and this is 1 times 10 to the 12th, negative 12th, excuse me. And then this is 1 meter equals 1 times 10 to the 12th picometers. And then, last but not least, we have femto with the symbol F, and this is 1 times 10 to the minus 15th, and therefore 1 meter equals 1 times 10 to the 15th femtometers. On the top there, those are the big prefixes, mega and kilo. And on the bottom are the small ones. So the small ones are deci all the way to femto, and in between are the base units. And so a helpful hint that I tell my students is always put the 1 with the bigger unit. So for example, mega is bigger. So that means like 1 mega anything is always going to have that 1 with it. So it takes a lot more of, for example, the meters to equal a megameter. So here are the steps to perform dimensional analysis. I like to use the known and the unknown. The known is what you know, the U is what you're trying to find, or your unknown. Then you write out your plan. This may or may not be something that you like to do. I find that in the past this has really helped students, so I'm going to suggest it, but you may use it for a little while, like maybe in the beginning, and choose not to use it toward the end. You then want to write your known and put it over 1. Write a multiplication sign and a fraction line, and then write your known units in the denominator. Here's an example. How many centimeters are in 2.7 meters? So our known, we're extracting it from the problem, is 2.7 meters, and our unknown is how many centimeters is equal to that. Next up, we go to the plan. So we have to go from meters into centimeters, and we do know a conversion factor. We actually saw one on the previous slide. Remember, centi is small compared to meter, so that means that we're going to have 1 meter equals 100 centimeters. Then we do our dimensional analysis. So this is kind of like our setup. This is going to help us as we do our dimensional analysis. Now comes the actual dimensional analysis part. So we're going to take our known and put it over 1, draw our multiplication sign and our line. We're going to take those known units and we're going to put in the denominator. And the reason why we do that is because we want those units to cancel. So if we have meters up there, that means meters has to go down there. So it has to go diagonal. And then on the top, that means that 100 centimeters is going to go on the top there. So notice meters over meters will cancel to leave the unit that you want, which is centimeters. So that means that I'm going to get 270 centimeters as my final answer. As far as significant figures are concerned, they're based off of the number that you start with. Okay, so that was a pretty simple example. This is a one-step problem because we have one conversion factor. Let's take a look at another one. So we'll use some time conversions here. It says how many seconds are in 1.50 weeks. So we're going to start with our known, which is 1.50 weeks. Our unknown is how many seconds. We're going to do our plan. We have to go from weeks to days, right? We know a conversion directly into that. From days to hours, from hours into minutes, and then minutes into seconds. And then I'm going to write down my conversion factors for each of those things. And then all I have to do is put them into the fractions when I'm doing my dimensional analysis. So with my dimensional analysis, I'm going to take my known and put it over 1. And I'm going to draw my multiplication sign and my line, just like the steps say. I'm going to put my known units in the bottom, right? So notice my first conversion factor is 1 week equals 7 days. So that means 1 week is going to have to go on the bottom, and then 7 days go on top. And then notice weeks and weeks cancels out. Then the next fraction has days going into hours. So I'm going to have 1 day, so 24 hours. And then the next one is hours into minutes. So it's going to be 1 hour is equal to 60 minutes. And then finally, I'm going to have 1 minute equal to 60 seconds. And now notice all the units cancel to leave the unit that I want, which in this case is seconds. When you do your calculation, you want to make sure you multiply by everything on top and divide by everything on bottom. And so in this case, if you do these calculations correctly, you should get 907,000 seconds. And again, my sig figs are based off of the number that I'm starting with, that 1.50. Since there's 3 sig figs there, that's going to be 3 sig figs in my answer. Let's try another one. So notice here, we're going from milligrams to kilograms. And so in this case, we're going to start out with 45,000 milligrams to how many kilograms? So when we do our plan here, we do not know a conversion that goes directly from milligrams into kilograms, right? Based on the other slide that we showed with all the prefixes, there's no direct conversion factor. So what that means is we're going to go from milligrams into grams, and then from grams into kilograms. And this is what you're going to do every single time you have a prefix with the base unit. So whenever you're going from a prefix to another prefix, you're going to do this every single time. So we're going to use the 1,000 milligrams to 1 gram and the 1,000 grams to 1 kilogram. So we'll start with the 45,000 milligrams. Again, we'll use our conversion factors. 1,000 milligrams to 1 gram, and then we have 1,000 grams to 1 kilogram. And then again, be careful here. Notice when you type this into your calculator, and I do recommend making sure you know how to do these calculations, type in 45,000, division sign 1,000, and then you have to hit the division sign again, 1,000. So you have to hit the division sign twice. And when you do that, you should get 0.045 kilograms. But again, to rehash what I just said about prefixes, whenever you're going from a prefix to another prefix, this will always have two conversion factors. You have to go through the base unit, which in this case, the base unit is grams. So our base units are grams, liters, and meters. And this will only happen whenever you go from one prefix to another. All right, I think this is our last example for today. So it says the Empire State Building is approximately 381 meters high. How many miles high is the Empire State Building? So our known is 381 meters, and our unknown is how many miles is that? So we're going to go from meters to centimeters because we know a conversion. And then we have to go from centimeters into inches, and then from inches into feet, and then from feet into miles. So we know the conversion from meters into centimeters is 1 equals 100. But then to go from centimeters to inches, this might be something you have to commit to memory. 2.54 centimeters equals 1 inch. And then there are 12 inches in a foot, and there are 5,280 feet in 1 mile. So now comes the dimensional analysis. So we're going to just start plugging in our numbers, making sure we go diagonal whenever we're trying to cancel our units. So that's the first conversion. The second one will look something like this. The third one will look something like this. And the fourth one will look something like this. And then when you do your calculation again, I highly recommend you do this on your calculator so you can make sure you know that you're typing it in correctly. Multiply 381 times 100 times the ones on the top. I guess you don't technically have to type those in. And then make sure you hit division sign 2.54, division sign 12, and then division sign 5,280. It's really important you hit the division sign 3 times there. And then you should get 0.237 miles for your answer. One final thing that's worth discussing, and you want to make sure that we're very clear on this, dimensional analysis is the method we will use to solve chemistry problems in this class. Although technically for some of these problems, moving the decimal point is how you can get the right answer, you are not going to be given credit for any problems not done using dimensional analysis. Failure to use dimensional analysis on homework quizzes, tests, and the like will result in a 0 for these assignments. So please make sure that you understand that's more important that you show how you're solving the problem as opposed to getting the right answer. If you have questions, make sure you check in with your teacher, but thank you so much for watching.